Okay, welcome back, kiddos. Now we are moving on to the most formal part of working with right triangles, which is working with trigonometry. Trigonometry. All right, and this is commonly known as trig. Okay, so what we're talking about with trig is we're talking about specifically trying to find out the lengths of the sides of any right triangle. Okay, if we just know the length of two of them in one of the angles, we can always figure out that third one. Okay, so here's what we're going to do. Okay, so our essential question is how is a right triangle used to find the tangent of an acute angle? And is there a unique right angle that must be used? Okay, so here's what we're going to talk about to identify that. So first thing we're going to do is identify the sides of a right triangle given an angle. So we're looking from the perspective of an angle. Okay, so let's take a look at this example right over here. Okay, so if we're saying given angle A, so if we're looking at the perspective from this angle right over here, okay, we want to label these sides: hypotenuse, opposite, and adjacent. Now the hypotenuse we always know is across from the right angle. Across from right angle. Right, so the hypotenuse is going to be AB. So let's go ahead and label that with an H. Okay, so we're going to label all of our sides. We're going to label that with an H. Now looking from A, from the perspective of A, I see this right over here. Okay, I'm just going to use a different color for this. So I'm going to look right across like I'm shooting an arrow. Okay, and this is my opposite side. Okay, opposite from A is going to be, I'm going to label with an O. That's going to be called BC. Okay, so a common mistake is to think opposite would be this side, right? Or opposite this side, but we know that's the hypotenuse, so we go across just like we're shooting an arrow, just like we did the hypotenuse. Okay, so if we do both of those, then we know the last one is what we call the adjacent. Okay, so sometimes it's tricky. We know the hypotenuse is tricky for the opposite and adjacent if we start with the adjacent. So I think if you start with the opposite, do the hypotenuse first, then you start with the opposite, then it's very easy because that one has to be the adjacent. Okay, so that one's going to be AC. Okay, so that's what we're going to do first is look from the perspective of the angle. So this is saying given from angle A, then this. So if we started from angle B, it would be a different perspective. Okay, and we'll identify that right now. So let's take a look at this. We're just going to identify the hypotenuse, opposite, and adjacent given the angle. So I want to see if you can do this first one at least on your own. Try this one. Pause the video and see what you can do, and then we'll try this next one. So given angle A. All right, so let's look. So if we're given from this perspective of angle A, okay, first off, the hypotenuse, right? So we know this one across from B is going to be the hypotenuse, okay? Then given from angle A, across from there, that's going to be the opposite, okay? And then the adjacent, okay? So we have hypotenuse, opposite, and adjacent. That's what we're going to label, okay? All right, so given that, let's see if you can get this one, all right? So on C, given angle C, all right? So from this perspective, okay, we know this one is the hypotenuse, right? Because it's across from that 90. From this one, that's going to be the opposite side, right? And if this is hypotenuse, that's opposite. This one has to be the adjacent, okay? So let's just put an X there because that's what we're trying to find. We're given that, okay? So that's what we need to know, all right? So that's our first part of our practice. Go to Delta Math and practice this. All right, hope we practice that on Delta Math. Now that we know that, let's get into the main crux of today's lesson. So we're going to talk about trig ratios starting today, and then we'll finish it tomorrow. So a ratio is a proportion, just like you see over here, of something to something. So trig ratios are the ratio of the lengths of two sides of a right triangle. So if we see this right triangle over here, the ratio of two sides is going to be either called the sine, the cosine, or the tangent. These are the abbreviations: sine, cosine, or tangent. Today we're going to be talking about tangent. Okay, so tangent is when we're talking about the length of the opposite leg over the length of the adjacent leg. Okay, so that's why we labeled those. So say we're looking from the perspective of A right over here. Okay, So if we're looking at the perspective of A right over here, we would say the tangent of A is equal to, right? So if we say that's the hypotenuse, this would be the opposite, that's the adjacent, right? That would be the opposite leg, which would be BC, over the adjacent leg, which would be AC. Okay? So those are the two that we're talking about. All right. So given that information, let's go ahead and take a look at what we have for today. So first off, what we have is, I'm sorry, hang on just a moment, please. All right, so here's the main thing. I know many of y'all like using the yellow calculator, but we need to mainly use this Desmos calculator because there's problems with that yellow one, especially on this. We have to have a calculator set to degree mode. So when we use our calculator, make sure this is set on degree mode. If it's not, you're going to get the wrong answer, even if you type everything incorrectly. Okay, so I'm showing you on this because the yellow calculator is not what we're going to be using on the test. Okay, so keeping that in mind, go ahead and pull up your Desmos calculator on that scientific calculator, and we'll use that on this. All right, so let's go ahead and take a look. First thing we're going to do is use trig to find a side length. We have two different types of problems here. First one, we're going to use it to find the side length, and then we're going to use trig to inverse trig to find an angle measure. Okay, so we use trig to find a side length and inverse trig to find an angle measure. So let's first check out the trig. All right, so the first thing we want to do is label. Okay, so let's look. It says solve for x. Okay, so x is right over here, round to the nearest tenth. So first off, we have is our hypotenuse, right? So we know this is our hypotenuse. Now let's look at the information we're given. Okay, we're given this angle B over here, right? So so label the sides with the given angle. So I don't know which one's the opposite until I know which angle, right? If I say it's opposite D, this one would be opposite. But we're looking at this 39, right? Because we look at the numbers we have. So opposite from there would be that. So if that's the hypotenuse and that's the opposite, this has to be the adjacent. Okay? So opposite, adjacent, and hypotenuse. So it says solve for x. Okay? Well, if we're trying to find that side and we know an angle, then we can use trig. Okay, so we're going to say the tangent of 39. So the tangent is opposite over adjacent, right? So we're going to say the tangent, so this is step number 2, the tangent of 39, right? So that's our 39 degrees. Tangent of 39 is going to be equal to, okay, so we're going to make our ratio, the opposite, which we know that's x right now, okay, right? X over our adjacent, which is 30. Okay, so that's it. We just set that up. All right, so step number 2. Okay, then step number 3, we're just going to cross multiply. Okay, so if I see this over here, let me go ahead and make that one a fraction. So if I put that over 1, then I can make that a fraction, and I'm going to cross multiply. All right, so 1 times x is still going to be x equals, right? Then we have tangent 39 times 30. Okay, so let's do it this way. 30 times the tangent of 39. So let's write that down. 30 first times the tangent of 39. So we're going to write 30 tangent 39. Okay, I know it looks a little weird, but that's all we got to do. All right, so now if we look, we already got x by itself. So we are actually done. We just need to type this into our calculator. So let's go ahead and pull up our Desmos. Okay, and let's just type this in. First off, we want to make sure it's in degree mode. See, if I push this, it goes to what we call radian. So I need to make sure it's in degree. It starts in degree, so we're good with that. So we're going to type in 30 tangent 39. So I'm going to type 30. And then I'm going to push this tangent button over here, and then 39. Okay, and I can push the last parentheses, but it knows it. So it says 24.29. Okay, so it says round to the nearest tenth. We know tenth means 1 decimal place, right? 1 decimal place. So we said x is going to approximately, we said 24.29, right? 24.29. That means x is approximately, we want to round to the nearest tenth, right? So we're going to do 24.3. We're rounding it to 24.3. Okay, so that's the basics of it right there. I know it seems different, but that's it. We're just going to set it up with opposite over adjacent and use our calculator. Okay, so now let's take a look at the next one. This one is, I forgot to actually put it into the notes. So let's go ahead and draw this one real quick. So if we drew this from our delta math, okay, we're going to make that right triangle. We're going to say that's the right triangle. We're going to say this is x. We're going to say this one is 61 degrees. Okay, and we're going to say this is 59. Okay, so given that, we need to find x. Okay, well, what do we know? Let's go ahead and first start by labeling our sides, right? So if this is the 90 degree, we know this has to be the hypotenuse, right? Okay, and if this is 61, that has to be the opposite, and this has to be the adjacent, right? So we're working with the opposite side and the adjacent, so we can use tangent. So we know tangent is equal to opposite over adjacent, right? So we're going to say the tangent of 61 is going to be equal to the ratio of 59 over x. Okay, so this is a little different from this. Okay, so if we notice, on this one I had x on the top. This one I have x on the bottom, but that's okay. This is a little bit different, all right? So let's do this. So let's cross multiply, right? So I do that. Now I have x times tangent of 61. So I'm going to write x times the tangent of 61 is just x tangent 61. Okay, so I know that looks a little weird. X times the tangent of 61 is x tangent 61. Now we have this times this, right? 1 times 59 is going to still be equal to 59. Okay? Now, I know that looks weird, but here's what we want to do. We want to get x by itself, right? So we want to divide by everything else. So I'm going to divide by tangent 61. I know that looks weird, but that's okay. So I'm going to divide that side by tangent 61, right? Because I have to if they're both equal. So now let's just do the math. That cancels out, and that's going to make it x. Now this can all go into my calculator. So I'm going to put that into my calculator. So let's go and do it. All right, so I'm just going to type in 59 over tangent of 61. Okay, so just going to push this blue button so I can have all my other stuff over there. So I can push this a over b to get my fraction. I'm going to put 59 on top. Okay, I'm going to go to the bottom. Okay, I'm just going to type in tangent 61. Okay, and it gives us 32.7. Okay, so x is approximately 32.7. Okay, so don't forget that. That's on that we do on that second one, so I forgot to add that in, but that's just a different type of problem. So those are the two different types of problems that we have. Okay, so this is going to be example number 1 right over here. Okay, and then this is example number 2. Okay, so keeping that in mind, let's keep it moving forward. All right, so we're going to actually skip this one right here for today, and we'll get to that in our practice. All right, so if we're trying to find the side length, we're going to use what's called trig. Now this is a little bit different, but this is okay. Now we're going to use, you can get this, inverse trig to find an angle measure. Okay, so that's the difference. Okay, we use trig to find a length, and we use inverse trig to find an angle measure. Okay, so inverse trig measures are used to find angle measures. Okay, so that's the difference. All right, so all we're going to do is say we're trying to find the measurement of angle A right over here, right? Now that's what we're trying to find. We're going to use inverse trig. So instead of tangent, we're going to say inverse tangent of this opposite over the adjacent will give us that. Okay, opposite over adjacent, because we still know that. So we're still going to use the opposite of adjacent, we're going to use inverse tangent. All right, so let's take a look. All right, so let's see over here. It wants to find x. Okay, so x is now this angle that we want to find. All right, so let's label our sides. For x, this is going to be the opposite. Right? This, of course, is the hypotenuse. So if that's the hypotenuse and that's the opposite, this has to be the adjacent. Okay, so we're going to say, okay, well, the tangent of x, right? The tangent of x is equal to the opposite, which is 8 over the adjacent, right? 8 over 4.9. Okay, so we said that the tangent of this measurement angle, right, is the opposite of the adjacent. But we want to find x. So here's what we're going to do. We're going to say the inverse tangent of 8 over 49 equals x. Okay, so this is pronounced inverse tangent. Okay, so inverse tangent of 8 over 49 is going to be equal to x. So now I'm just going to type this into my calculator. Alright, so let's go ahead and take our calculator. This is a little weird. Alright, it's okay, but we're going to do this. So inverse tangent, we're going to have to find our inverse. So we're going to push that function button. Now we see this. Alright, so it's inverse tangent. I'm going to type that. We see just like we had over here. 8. So now I'm going to go back to my main. Right? So I can push this right over here. 8 over 4.9. Okay, and it gives me 58.51. Okay, so it's approximately 58.51, which that means it's approximately 58.5. Okay, so I know it looks a little weird, but that's all we have to do. We just have to say inverse tangent if we're trying to find the angle measurement, right? That tells us it's an angle, right? If it's a degree. All right, so let's keep that in mind. Let's keep it moving. What about this one? Find the measurement of angle T. Okay, now on angle T is this right here, so we want to find that, right? So if we're trying to find the inverse, so we're going to say x is going to be equal to the inverse tangent. Well, I moved ahead. Let's look at what we can do, right? This is the hypotenuse, right? This is the opposite, and this is the adjacent. So we know the opposite length and the adjacent, so we can use tangent to figure out x, right? Because x is the angle measurement for t. All right, so let's say 21 square roots of 3 over 71, right? Opposite over adjacent. So let's just type that into our calculator. Okay, so we're going to say, let's go push that function button. We're going to say inverse tangent. Go back to our main. Push this of 21 square roots of 3. Okay, going to go to the bottom over 71. Okay, and it gives us 21.12. So x, 21.12. X is approximately 21.12, right? 27.12, right? 27.12. So that means x is approximately 27.1. Okay, so that's all we have to do. Okay, so this is neither one is super difficult. It's just we have to look at it from the right perspective, right? So if we're looking for the angle, we're going to use inverse trig. If we're trying to find the side, we're going to use regular trig. All right, so now let's look at this last one. It says find the angle of elevation. So if we're trying to find the angle, that means we use inverse trig, right? Okay, when the sun has a 12.5 meter tall, find the angle elevation of the sun, right? When this tall meter pole casts a shadow that's 18. So this pole makes this shadow on the ground of 18. We want to know what angle that is if we're looking right over here, right? So if we're right over here and we're looking up at the sun, right? What would be that angle? So that means we need to use inverse trig. So we're going to say the inverse trig of, if this is the opposite, that's the adjacent, right? 12.5 over 18, right? So see if you can find that right answer. All right, hopefully you tried. So we're going to say, go to our function. We're going to say inverse trig of, go back to our main, hit this, opposite, which is 12.5, over the adjacent of 18, gives us 34.77. Okay, so x is approximately 34.77, which we said is 34 point, what would that be? 8, right? Oh, and then degrees. Okay, so that's our answer. So, That's all we got to do first is we want to label the sides with the given angle. So figure out which perspective you're looking for, the opposite and the adjacent, then just set it up. Use trig if you're finding a side length. Use inverse trig to find an angle measure. This is the first example right here where we have when x is on top. This is a second example, so when we have to divide by that tangent. So let me know if you have any questions, but I know you can do this, and we can definitely do this in class.